This is Curated. In today's video, we're going to be looking at scalar quantities versus vector quantities. Now, both scalar and vector quantities are physical quantities, okay, meaning that they are physical, okay, such as time or distance or speed or mass. These are physical quantities, and that's why we call it physics, right? So, a scalar versus vector quantity. What is a scalar? A scalar is a physical quantity that has magnitude. All right, magnitude. What is magnitude? If we were talking about mass, for instance, right? Mass of a house, okay? And this house weighed 1,000,000 kilograms, which is pretty heavy, but that's how much a house could weigh, right? 1,000,000 kilograms. It has a million, its magnitude, and it's kilograms, right? That there is a great example. Another example of a scalar quantity is distance, all right? Distance refers to the distance or the length of a path traveled. For instance, if I was to run 3 kilometers, all right, around my house, that 3 kilometers would be its magnitude, okay? And the next thing is speed. All right, speed, we all know what speed is: the speed of a car, speed of an aeroplane, speed of light, right? These are scalars because they have magnitude. And finally, something like temperature, okay? The temperature outside, it might be cold, it might be hot, all right? It has a magnitude to it. We can measure it, and that's why it is a scalar quantity. Now, a vector physical quantity is something that has both magnitude, okay, but also direction. And a way to remember that is that this vector, this V, can be converted into an arrow. And this arrow represents the direction that vectors have and scalars don't. Okay, so let's look at a few examples of vector quantities. All right. Another one, or one, is displacement. All right. Displacement. And now displacement, all right, is a change in position. All right. Now, what do we mean by change in position? If, again, I was doing this 3-kilometer run, all right, and I started here and I ran around and around, I don't know why I made a circle like that, and I ran around and around, okay, that is the distance, okay, but the displacement is this single straight line. We're going to be looking at an example like that, all right, just to further understand what a scalar is versus a vector, so we can get a complete understanding of it. All right, another example is velocity. Now, velocity is speed combined with a direction. So if we had a car, for instance, okay, and this car was traveling at 100 kilometers an hour, that is its speed. But if all of a sudden we add the fact that it's traveling north, okay, traveling north, then it is velocity because it is a vector. It has both magnitude and direction, all right? And then we also have things like forces, all right? Forces are also vectors because forces need direction, and also acceleration, all right? And as we go along with our syllabus in physics, we're going to be looking at deeper explanations of vectors versus scalars in more specific terms. All right, so let's look at one example of a scalar versus a vector, okay? And that is, I have a friend, right? And his name is Tony, and he comes to my house all the time. He rides his bike all the time towards my house. So he starts here because we live quite close by. This is his house. All right, his house is all the way over there, and my house is over here. This is my house, okay? And he has to take this bike ride, right? He chooses to take this bike ride because it's safe for him, all right? And he comes to my house, for homework and a bunch of different things, right? So he wants to take this route. He takes this red route, and he goes all the way this way because it's safe for him, right? Cool, all right? And that is the distance that he travels, and it's round about 5 kilometers. That is its distance because it is the length of the path that he traveled. This red line represents the length of his path. All right, this 5 kilometers. Okay, now if all of a sudden he could take this distance right here, this is his displacement. Okay, and his displacement, as you can see, is much, much shorter, even though the word is much longer. And that's maybe a way to remember it, that even though displacement is a much longer word, all right, it represents the shorter distance, or well, a change in position, right? The definition of displacement is a change in position, right? And my friend Towner, if he could just travel the displacement all the time, it would only be like 1 kilometer, right? He wouldn't have to go this entire red route that is so, useless, all right? He could just, take the blue route and he'd be done, all right? But distance, all right, distance is the length of the path traveled. All right, and that there is a difference, and now we can see. Now you might be saying, how does this relate to scalars versus vectors? All right, now the distance is very just 5 kilometers, but when we talk about displacement, you have to talk about the fact that he's traveling 1 kilometer, but he's traveling 1 kilometer southeast. All right, that is roundabout southeast. Okay, and that's so important. And the reason for this is because in any way or any path traveled, all right, for instance, if we had this path here, okay, we started at this point over here and ended up at this point here. That there, as we know, it's the distance. Correct, that's wonderful, right? But this yellow path is the displacement, right? Now, we can see obviously the difference between the distance and the displacement, all right? The displacement is just its change in position. But you see, the distance, first of all, he travels west, all right? Then he tries to travel south, all right? Further south he goes, and then he travels a little bit northwest to this position. But in displacement, he is moving one way, all right? He's moving one way, and that is southwest. It's just in this one direction. And that's why displacement is a vector. All right, because no matter what it is, it's always going to be a straight line because it's just this change in position, and therefore it's always going to be in one direction. And that is why displacement is a vector, whereas distance is a scalar, because we can't put direction on the distance, all right, because first of all, he's going west, all right, then he's going south, then he's going further south, all right, then all of a sudden now he's going north, he's going northwest all of a sudden. Okay, but the overall is southwest. All right. I really hope that helped you understand the difference between scalar quantities and vector quantities, and the example of my friend helped. If it did, I'm so happy. That makes me feel so good. Have a great day. Stay healthy. Please subscribe if this video helped you, and leave me a like so I know that it did. Thank you so much. Have a great day.